Alright, for today's lesson, we're going to draw energy bar charts and calculate the velocity at each location for a scenario. Now, the scenario that we got here is we have a bowling ball and it's swinging like a pendulum from left to right. So that bowling ball, it's got some different types of energy, especially at each location. We have A, B, and C, and it also gives you the starting height at 10 meters, and it gives you the height at the bottom, obviously 0, and then at location C it rose back up to 5 meters, and it's still moving at C. It also tells you the mass of that bowling ball. It's 4 kilograms. And so we have all the information here if we wanted to draw energy bar charts at each location and calculate the velocity at each location. So what are we going to do? Let's look at this first location, location A, and we're going to use the mass, and we're going to use the height, and we're going to calculate how much energy it has. But we need to know what type. We know that at this location it's going to have gravitational potential energy because it's really high up. It's lifted up. And it should not have any kinetic energy. That's right. Because it's at the top of its path, it comes to a stop before swinging back down. So we know that its kinetic energy is going to be 0 joules. So that gives us a lot of insight already. So we already know quite a bit. We know the mass, we know the height, we know that it's got 0 joules of kinetic energy, and we know that it's got gravitational potential energy. So let's draw the energy bar chart. So here we're at location A, and we know how to calculate gravitational potential energy. It's mass times little g, the acceleration due to gravity, times the height. In this case, the mass was 4 kilograms. Little g is always 10 meters per second, and the height is 10. 4 times 10 times 10 is 400 joules. Perfect. So we're going to draw a little bar graph here that tells us that we have 400 joules. I snuck one down here, so I'll just use this guy. This little bar chart here, it represents 400. This is telling us that we have 400 joules of energy wrapped up in this gravitational field right here, with this bowling ball lifted in the air. Now, how do I calculate total mechanical energy? Well, it doesn't have any kinetic energy, so all of its mechanical energy is gravitational potential energy. So in order to find mechanical energy, you just do UG plus K. So I'm just going to copy this guy over. Alright, these should be the same height, the height of those bars. Okay, so we've calculated, right, remember that we're also calculating the velocity. We also are supposed to be calculating the velocity, but at location A it's really easy because right here it's going 0 meters per second. It's at the very top of its path where it comes to rest. Now, location B. Location B, pretty simple. If we look at our if we look at our scenario here, the bowling ball swings down. It loses all of its height, so it should have no gravitational potential energy. Its gravitational potential energy should be 0 joules. And remember, it had 400 joules of energy at the top. And the conservation of energy states that that energy cannot be created or destroyed, only transformed or transferred. But in this case, all of its gravitational potential energy has transformed into, you guessed it, kinetic energy. So it should have 400 joules. If it has 400 joules at the top, it should have 400 joules at the bottom. I'm just going to erase that so that my slide doesn't look really bad. Okay, so that makes it really easy to create our energy bar chart. It should have 400 joules of kinetic energy. I'm going to copy this here because it's the right height. So we got this represents 400 joules of kinetic energy. We should have no gravitational potential energy. Gravitational potential energy plus kinetic energy equals its mechanical energy. And so all of its mechanical energy is wrapped up in its energy of motion, its kinetic energy. Okay, now remember, we got to calculate velocity, but we can do that. Super simple. You just use a handy dandy formula. We know that kinetic energy is 1/2 times the mass times the velocity squared, and we know that its kinetic energy is 400 joules. So we're going to do some algebra. Multiply this side by 2, this cancels out. Whatever you do to one side, you do to the other. 400 times 2 is 800 equals mass times velocity squared. And we're continuing in our super duper math skills. Instead of just an m there, we know that its mass is 4 kilograms. And let's get v squared by itself. These cancel out. Whatever you do to one side, you do to the other. And v squared equals, what's 800 divided by 4? It's 200. Now, how do you get rid of this little square right there? Well, you take a square root of both sides. V equals the square root of 200 meters per second. And the square root of 200, let me do it on my calculator real quick. It's about 14.14 meters per second. So we used this equation, the equation for kinetic energy, to solve for velocity, which gives us this number right here. So we know that at location B, this this bowling ball is plugging along at about 14.14 meters per second. It's moving pretty fast. Okay, that leaves the last location, location C. I'm going to let you guys do this one. Now the key to location C is remembering that if it had 400 joules there, it's got 400 joules there, and it's going to have 400 joules of energy at C. So that you know that its total energy, here we have location C, you know that its total energy, this is going to be 400 joules. Now how do you calculate gravitational potential energy? You use m times g times h, and whatever's left over is going to be kinetic. All right.